Every digital device uses the binary number system to store and process information. But why the binary number system and not the decimal number system that we are used to work with? Before we explore why it is used, let's look at the differences between the two. With the decimal number system, every digit has 10 possible states, from 0 to 9. The rightmost digit has a value of 1 times the number at that digit, and every time we go one digit to the left, the value is worth 10 times more. If we use 1234 as an example, the number is made up of 4 times 1, 3 times 10, 2 times 100 and 1 times 1000. With the binary number system, every digit only has 2 possible states, 0 or 1. The rightmost digit has a value of 1 times the number at that digit, and every time we go one digit to the left, the value is doubled. For example, the binary number 1011 is made up of 1 times 1 plus 1 times 2 plus 0 times 4 plus 1 times 8, which is equal to the decimal number 11. One digit of a binary number is also called a bit, so this number is a 4-bit binary number. 8-bit binary numbers are also called a byte. Okay, now that we know what a binary number is, why are they used with digital devices? Suppose we have two devices that are connected with a single copper wire. On the left is the sender and on the right is the receiver. How can these two devices communicate with each other using only this wire? There is not much we can do with the wire, but one thing we can do, since it is a copper wire, is sending electricity through it. Doing that, there are only 2 possible states at a given time. Electricity is flowing through the wire or no electricity is flowing through the wire. This is why the binary number system is used. As explained earlier, the binary number system uses 2 states per digit, making it the ideal number system for transmitting data with electricity, because one digit can simply represent electricity or no electricity. But how do we now transfer information using only these 2 states? We simply do it multiple times. For example, we could say that we send 1 bit every second by either sending electricity through the wire or not, for the duration of that second. Using this frequency, we can transmit 1 binary digit per second, also called 1 bit per second. Let's try to transfer the binary number that we saw earlier with this technique. We need to transfer 4 binary digits, so we need 4 seconds to transfer the whole number. The first bit is a 1, so the sender will send electrical current through the wire for the entire first second. The second number is a 0, so the sender simply does nothing. The third digit is a 1 again, and finally the fourth digit is a 1 as well. Now after 4 seconds, the receiver successfully received 4 bits of data. This means we have successfully transferred the decimal number 11 through the wire using the binary number system. You now know how to transfer data using only a wire and the binary number system. Today things are a bit more complicated due to error checking and the high frequencies that are used. For example, a modern Cat8 network cable uses a frequency of 2000 MHz, meaning 2 billion times per second. For a short exercise, try to translate this 8-bit binary number or byte to decimal. Remember, the rightmost value is 1 and it doubles every time you go 1 to the left. Stop the video now. If your answer is 25, you are wrong, because the right answer is 26. You don't have to be able to fluently translate from binary to decimal or vice versa to be able to become a programmer. You only have to know how it works. In the next video, we will look at programming languages and how they work. It will not take long until we write the first line of code. See you in the next one.